Hey everybody, here's another video of graphing rational functions. This is the first one on your homework if you want a free problem. Okay, so as with the last example, if you watched it, you're going to start by checking out the degree of the numerator and the denominator. Since they're both quadratic, we know that there's going to be a horizontal asymptote at the ratio of the leading coefficients. So 2 over 1, or just 2. So there's our horizontal asymptote at y equals 2. Okay. Now I'm going to factor both numerator and denominator. And I notice I have repeated factors of 0, or well, repeated factors of x, which would have zeros of 0. So those would cancel out, but I'm still going to have a domain restriction when x equals 0. So remember, that shows up as a hole on the graph. So the denominator here tells me that I have a vertical asymptote at x equals -2. And those x's that I reduced away tell me that there's going to be a hole at 0, something. It's the 0 because that's what will zero out both the numerator and the denominator. And then to find out that y value, I'm going to plug 0 in for x. So that's going to give me -4 if I plug that in. So -4, 0, -4 is going to be the hole in my graph. I can also see that because of this set of parentheses, x equals 4 is a 0. And there's not really any other interesting information. We know that there's not going to be a slant asymptote because there's a horizontal asymptote. We got the only vertical asymptote. We got the hole already. We found the only 0 of the numerator, so that's the only place the function equals 0, because that's the only thing that you can plug in to get 0. So now we have to start plugging stuff in. So I started at plugging in -6. I kind of trust that you guys can do this on your own. When I plugged in -6, I got 3.5. You're going to get rational numbers for these when you plug these in because you're plugging them into a ratio. You're going to get integers in the top and bottom. So I got -6, 3.5. And I got -5, 4 1/3. And -4, 6. And -3, 11, which is just off the top of my graph, but I can still draw it. So when that sort of thing happens, when I can see this shape, I'm going to approach from the asymptote and kind of swoop through my points and go towards infinity. You can continue to plug in points. You've got -1, 9. Obviously, the hole that we already graphed. 1, -2 1/3. 3, -1. 4, -2/3. But at a certain point, you'll have reached enough specificity, or you'll be accurate enough that you'll be able to say, all right, I'm going to come from the asymptote and kind of swoop through my points. I know swoop through is not the most technically accurate term, but that's enough for us here to get a good picture of how this graph looks. All right, I hope that's helpful.